And yes, Ahmet, you're very much welcome. Let's start.
Thank you very much for the nice introduction, and thanks for having me here to give the floor for presenting one of the recent work. Very briefly about myself, I'm a researcher at Cohere. I used to be in the team that called Cohere Labs, which is a research branch of Cohere and works on fundamental research areas, multilinguality, and broader. I mean, not only multilinguality, but lots of kind of pure research directions centered in the LLMs in general. Currently, I am also leading the code agents team. So, but this presentation is nothing about the code agents. It's more about our work on multilinguality and the Tiny AI. Also, one quick disclaimer that I directly used most of the slides from Julia's presentation. So it's a kind of a huge shout out to Julia to present all of the slides here. But yeah, I used most of them. I'm not sure any of you already knew about Aya model family, but the Aya model family actually didn't start with the Tiny Aya. For I think almost the 3 years ago, we started with a open science project to collect lots of multilingual instruction fine-tuning data, which was like a root origin of the Aya project. But from that time to now, I will show a little bit more later, but we developed multiple models with the name of Aya that targets the multilingual access for the large language models. But in particular, with the Tiny Aya, our main kind of main question, let's say, how can we balance the multilingual performance at the small scale with a loss of languages? Because if you think about creating a multilingual model, one of the major reasons that you may want to create a multilingual model is increase the accessibility to large language models, right? But at the same time, if you ask anybody in the LLM space how to create a language model that has more languages, I think easier answer would be, okay, let's train a bigger model. But at the same time, if you want to build something very accessible for lots of people that speaks different languages, also accessibility kind of has this inherent requirement that smaller is better, right? Because that's way people can actually access the models. That's why we take this building a small multilingual language model is a design problem. Actually, Tiny AI is kind of our answer how to approach this problem rather than a one model only. This is like a long TLDR, basically. Of course, I will go all the details as much as possible about how we build and how we measure the success with a Tiny AI. But at the end of all this, experiments and procedure, we actually release multiple models called Tiny AI, includes a pre-trained model and includes 3 regional, like clustered instruction tune models that targets different language groups, and which was the main point, right? How can we train something? Doesn't need to be a one model. Train a family of models that has strong performance in the long tail, not only in few selected languages. Yeah. Actually, so I will make it faster here. This is a very brief kind of summary of the Aya model family. As I said, in 2023, we started with this very big open science project to collect lots of multilingual instruction tuning data. Together with that project, we actually trained a model called Aya 101. That is really the model that we want to showcase that is possible to build a language model in an open domain that has lots of languages with a considerable performance, let's say in that way. From Aya 101 to Aya Expanse, actually we set some of the roots of the Aya models, that we set some benchmarks, and we showed that with a really well-designed post-training recipe, you can actually generate and produce a state-of-the-art language models in multiple languages. And just before Tiny Aya, we actually even expanded the Aya family from text to multimodality to vision, and we released a model called Aya Vision, family of models, Aya Vision, that has also strong performance on multimodal language understanding. With Tiny Aya, as I said, we kind of the main target there, because all the IA model family after IA 101 was including like 23 languages because of the pre-trained model that we start with. And with the tiny IA, the question, okay, how can we increase the language expansion? But at the same time, how can we decrease the model size, which was actually counterintuitive and is much more challenging than taking only one approach. For those who didn't see the release and everything, actually, I can also share the slides after the talk, but we have very detailed technical report. It would be nice if anybody interested looking into. We have a demo, and yeah, the models are at Hugging Face. So feel free to play and check how that works for the languages that you speak. For today's talk, I will start with the pre-training. So some parts might be more extended, some parts might be a little bit faster. So feel free to jump in and ask any question. So I definitely don't mind to being interrupted and talk about the more interesting parts with you guys. But let me start with pre-training, because as I said, one of the things we start with the tiny AI is actually starting from the zero. We want to pre-train a small model that has much more language coverage than our previous models like IA Expanse or IA Vision. When you start with the pre-training model, especially in terms of if the question is how to extend the language coverage, of course, the first question is always tokenization, right? Tokenizer, because language models start with a vocabulary, and that is really kind of a predefined how well this language model will cover multiple languages. This is because scripts, also this is because of training data distribution. And since I already told that we actually released 3 different language models, the instruction tune that kind of optimize different language groups, approaching the tokenization problem is not really straightforward, because normally when you want to pre-train a language model, and when you train a tokenizer as step 0 for the pre-training, you have a data distribution in the pre-training. Normally, you take the data distribution as is to train the tokenizer. But that is actually not the best way for multilingual language models, because potentially your data distribution would be quite skewed through the higher source languages. So there's much less tokens in the lower source languages. But at the same time, especially for the tiny AI, since we want to release 3 different optimized language models, there is no one certain data distribution, right? So because if we want to target the Asian languages, data distribution is skewed through the Asian languages, but there are also languages in African languages that skewness actually doesn't allow the tokenizer to learn enough representation for other languages. But in general, what we really want, so we want one tokenizer kind of covers with a balanced distribution for higher source languages, lower source languages in one dimension, but also languages that is clustered in different regions with the balanced representation. So our approach is a sort of innovation there, actually. So let me make this smaller. Yeah. Our innovation or our approach to kind of look at this problem was, okay, we want to use the data distribution, because if our tokenizer data distribution is fundamentally different than training data distribution, then the training efficiency would be extremely low, because we want also training efficiency in terms of number of tokens should be high. But at the same time, as I said, we want to balance the language distribution. Here we take a formulation that, the details are not super, if you look at the technical report, you can probably see the details, but more important, we take these 2 prior and combine them. We take a prior from the data weights, from the training data, but also we bucketed the languages based on their language family and the scripts, and take another prior from that distribution, so that we can combine and kind of get balanced language distribution to train the tokenizer. This is not in the technical report, but this is from the paper actually that kind of originates our tokenization approach. Paper name is called One Tokenizer to Rule Them All. Here we compare like an extremely simple approach, which would be like if you uniform distribute the weights across different languages, versus you take this like a data and bucketed weight approach. And here you can see actually the dark blue bars, the coverage. This is actually win rate, but we think the win rate, of course, in terms of the downstream performance, very much align with the tokenization coverage in the context of this paper's experiment. Our weighted approach generates much better performance and obviously much better language coverage. That was the one of approach that we take for tokenization from step 0. Yes, with this language distribution, how then, of course, the question is training a tokenizer. Another important thing is actually there, the vocabulary size. And here we actually really train a very large vocabulary tokenizer. So if you look at Gemma 3, for example, which is also a very strong multilingual model, their tokenizer is, I think, has 250 K vocabulary. So we kind of use somewhat similar approach, but also increase a little bit more. And at the end, we use like a 262,000 vocabulary that spans over all this, over 70 languages. And in terms of the training data for the tokenizer, we use FineWeb2, which you can access publicly in Hugging Face. And we, of course, we have to subsample quite a bit. And we only use 50 GB data to train the tokenizer there. And this is, at the end, is actually a very nice comparison with our tokenizer, Gemma 3 tokenizer, Qwen 3 tokenizer. All these models are pretty strong in multilingual domain. And of course, here, what we want like a lower is better, right? This is kind of compression, how well model tokenizer compress the tokens. So we want each tokenizer actually compress as much as possible within broad range of scripts here. And as you can see, TinyAI actually has quite a good performance across all the scripts that you can see. And in majority of them has the best performance. Tokenizer was the step 1, step 0. Then the step 1, of course, the main thing is pre-training. So in total, TinyAI has been pre-trained for 6 trillion tokens for more than 70 languages, but in general, we make sure that it covers 70 languages. In terms of the data pipeline, I don't think this is extremely novel, but it's really important, especially the details. We collect large sources of data. This is our starting point. Then we balance how we balance the tokenizer. We also balance the pre-training data there. And for those maybe experimented with pre-training, obviously this is much more costly, but you may know that the quality of the pre-training data actually extremely important. So as much as filter you apply to pre-training data, potentially you will get a better performance. That's why we did lots of heuristic and different filtering approaches there, like a language ID filtering, heuristic cleaning, because in the web raw data, there are lots of noise in the data, deduplication, and some quality filtering, just like similar with FineWeb Edu, for example. And at the end, we have another phase. This is becoming a more like a general approach now in the field, has like a mid-training or cooldown that we kind of have a different distribution of the data, that we upsample the high quality portion of the pre-training data set and add some instruction tuning data sets to finalize the pre-training. But if you ask me, like, what is the most important thing in terms of the pre-training in this step, is actually how to produce cheap and useful signal for the large pre-training runs, because pre-training is extremely costly. Even for 3 billion parameter language model, it takes quite a long time, depends on how many GPUs that you are using. But one thing that we really want from the pre-training perspective, we want to get the best signal as soon as possible, right? So because this is supposed to be cheap, and we want to get really useful signals about the data or about hyperparameter choices. So one thing that really helped us in terms of this one is our learning rate scheduler. Instead of using a somewhat common cosine learning rate, we use WST, which is warm-up stable decay learning rate, because this allows you to take it a bit more flexible in terms of the duration of the pre-training. For example, you can experiment with the 4 trillion token pre-training, 6 trillion token pre-training, or 8 trillion token pre-training, because these steps probably will be under the stable line of the learning rate. But also this is not enough, right? WST learning rate scheduler actually quite interesting learning rate scheduler, because the most you get as a gain, you get at the end of the training, which is called cooldown era. When you start decreasing the learning rate, model learn the most. So if you only experiment small scale, if you only do the small scale experiments in the stable line of the learning rate, probably you won't get the best signals from the pre-training experiments. That's why what we did at the end, do small scale pre-training experiments, but always do together with the cool down as well. Let's say I think majority of our pre-training experiments, we use 200 billion tokens, which is somewhat cheaper. Of course, this is a relative thing, but also always use, I think, 40 billion token cooldown so that we can kind of have a best comparison simulating the end of the pre-training. So this will really help us to pick the hyperparameters, to do loss of data ablations. And at the end, we pick all these best choices and scale up to the end. I will stop a bit before moving to post-training. If there is any question about the pre-training, I would like to discuss that.
Can you please shortly maybe let us know how much time actually did it take, or maybe you mentioned?
Yes, I cannot exactly say in terms of the at least the number is not in my mind, but of course this is very much dependent on the number of GPUs that we use. But we used 256 GPUs, then our setup was pretty optimized. So I think it took maybe a little less than a month. But of course, there are lots of choices there in terms of the precision that you use in the pre-training, right? So we used FP8 precision for majority of the weights, at least in the computation time. That also made the pre-training much more faster. And of course, there's lots of sharding experiments needs to be done to find the best speed up for that pre-training. But unfortunately, I don't have the number in my mind for full time.
Yeah, exactly, because I think you really spent quite some time to figure out this best setup that works for the model. So yeah, it's I don't know how half a year of research was happened before to have this then done in a month.
Indeed, yeah. I think the largest time that we spent for TinyAI was finding out the best recipe for pre-training and tokenization. Then we scale up the pre-training and we start researching on the post-training recipe. That was kind of the approach that we took, because pre-training took a bit of time, obviously. All right, for the post-training, I think the most important thing, especially for the small models, but actually for the model that has lots of languages, is so there are lots of languages that you may not have any a super high quality data, and translation might not be the best approach to directly apply, because translation models also might not be super good at some of these languages, right? So that's why actually we experimented quite a bit to find the best recipe, combining translation, combining different teachers, because there are some languages that you may have really strong models that you can kind of generate lots of distillation data. But for some languages, none of the open source teacher models may not really work well. So most of our pre-training research was kind of focused on these two areas. Yes, and our kind of finding was, okay, we should generate the post-training data synthetically through multi-stage approach with multiple teachers, and a kind of for the translation approach, we actually want to, because there is this real danger of having data that has lots of translation is artifact, and we try to make the data much more natural and much more fluent in all the languages. So I will tell what does it exactly mean, but that was our main approach. So how we take it, let's say we have a source data in English. We first thing to check is how to translate that. So we use their Command A Translate, which is state-of-the-art translation model from Cohere that works in 23 languages. For the languages that Command A Translate does not really cover, we use DeepSeek V3 there. And to estimate the translation quality, which is quite an important thing there, we use either Xcomet XL or AfriComet, because Xcomet XL also doesn't cover well for all languages. That was the first step. Then we look at the prompt first. Of course, we are doing in terms of the prompt level first. We are not really generating the completions yet. And we look at the prompts. If the prompts are high of a quality, then we take these prompts to generate the completions. But if the prompts are not high of a quality, which is also quite a case for lots of languages, then we actually first try to solve how to get the best quality for the prompts. There we used this fusion approach that we kind of fuse multiple teachers like a quality to generate the best prompt. And also we kind of augmented data to make it more difficult or more natural in that corresponding language to generate the best prompt. When we have the pull of the highest quality prompt through either directly translating or using fusion and data augmentation, then we use again the fusion approach to generate the completions for the full post-training data. Yeah, I think I kind of cover this part. In terms of the prompt level augmentation or transformation, these are the kind of metrics or areas that actually we looked at. Naturalness, like how culturally relevant that prompt is, and a difficult adjustment. We see all of these three really has lots of impact. Some of the impacts can be measurable in the downstream performance, but some of the impacts may not be easily measurable if you only look at the scores. But actually, it makes quite a bit of difference in terms of use of that language model. And we created lots of rubrics to measure this culturalness or cultural relevantness or like a difficulty. That was a kind of approach that we took. And the corresponding paper is actually The Art of Asking, you can find in the archive, that actually has research on this particular focus. It was a separate research paper as well. So we kind of combined in the TinyAI. Yeah, I mean, this is kind of, I don't want to get into details, but this is kind of shows our pipeline. We have a seed prompt. Then as I said, we do the translation. Then we do kind of naturalization with again, LLM as a judge and using other LLMs to make the prompt most relevant and culturally and most natural there. In terms of the fusion, this is also, by the way, these are all separate research that we published and we combined in the TinyAI. This is another research focus was focusing on like a post-training side of TinyAI and kind of published just before TinyAI there. Instead of using only one teacher for each prompt, we use multiple teachers. But actually, this is pretty common in the field. Now, if you think about the best of N, you can sample from multiple teachers and try to pick the best completion for each prompt, right? Actually, we took one step further. Instead of doing like a simple best of N from the best teacher, we sample from multiple teachers, then using another teacher, in our case, it was Command A, we kind of fuse all the completions. So what this gives us, this first of all, prevent having a bias from particular model, because in a language, Command A might be the best teacher, but in another language, Geometry 27B could be the best language. But if you only use this best of N sort of approach, you may end up having a post-training data. It's kind of one language, it's loss of Command A data, one language, loss of DeepSeek data, and it kind of creates a interference inside the training data that you have. So, but if you kind of fuse with a model, but then you pick the best of both worlds, but not best of N, because now you have no bias from one model, kind of more natural distribution in the data, but also, of course, you use the best characteristic of all these teachers. That was our kind of reasoning, and that's shown to be really improving factor for the post-training data synthesis operation. We have this side quest during the post-training data, because we want also TinyAI really good at machine translation, because especially this size of models, machine translation is really, really one of the most important tasks. People probably will take the model, deploy in their edge device, and maybe use for translation. Even it is possible in a day-to-day manner. That's why we really want model to be really good at machine translation. But the question there, if you overshoot the data in machine translation, then your model becomes machine translation model rather than a general purpose language model, right? So we kind of followed the same approach that has been presented in Command A Translate, that leads Command A Translate to be the best, one of the best model in machine translation, actually state of the art, as I said, in 23 languages. But the gist of it is actually not more data, but less highest quality data. So we did lots of cleaning and filtering to like filter down the data sets to a kind of significant but enough but significant amount with the lots of different filtering. So I won't go into details because it's all of them in command and translate, but it includes rule-based filtering again, difficulty filtering, which come up again, this difficulty is as an important metric. And also we looked at some way of online capability filtering, which I can tell a bit more if it's an interest, but it's all in command and translate paper. Yeah. At the end of the day, these are the ways to generate the training data, right? But always there is this question, how to oops, yeah, how to have the balance across different languages. From the get-go, actually, from the start, we really wanted to release TinyAI in multiple as a multiple language model with focus areas in terms of different languages. So we kind of cluster these languages in European languages in one cluster, South Asian, Asia Pacific languages in other cluster, and African languages also put inside the most relevant cluster, so that we can actually optimize the language performance, but also try to both balance but also language performance, because this is two different angles, right? Yes. So how we did the balancing? I guess this would be the quite important question there. Actually, there are lots of manual experimentation happened there, because like let's think about you have 4 different clusters. Our experiments were like removing some of the languages from one cluster, running the post-training experiment, seeing the performance in that cluster, but also seeing the performance in the other cluster. So this language balancing indeed includes lots of different experimentation. And at the end, we picked what works best in terms of combining what different languages. For example, European languages and African languages end up being the best also for African languages. That's why this cluster has European and African languages together. One other thing here, it's not very well represented in the image, but we also use code data, both in, of course, pre-training, but also post-training, with different percentage in all clusters, because there is this kind of prior that in some of our research we also showed, but also some other papers shows that code data helps natural language performance. So we always add code data, but based on the language balancing, we also balance the code data and other code adjacent data in the post-training as well. Yeah, actually, I would like to talk a little bit about this very quickly, and also I want to talk about the evaluation. That's why I'm skipping a bit fast some of the parts. One thing that is kind of shown very successful in multiple research, but also in our previous IA research, model merging is actually quite a nice way to, is a kind of the method that is inherent to post-training now in most of for the most of the labs. We also use model merging because we train lots of different language model in different cluster with different clustered languages. But at the end, to get the best performance covering more language balance, we experimented with merging different language cluster as well. So one, for example, we have a pre-trained base model. We train a post-trained model using all the languages, which is actually corresponds to this TinyAI global. This has the post-training data from all the languages. And we use this TinyAI global as a merging candidate for all other clusters. So that was a really nice balancing factor, so that any language model that like this any language model that targets different region is not extremely optimized on that region, but also has a general performance as well. Because let's assume that you want to use a language model that is really good at African languages, but there might be lots of code switch data, or there might be data like there might be tasks that like translation, you may want to use African language with some other languages. We always want to have some global language performance in all the clusters, and actually merging kind of helped for us. For the merging recipe, we have another paper here, a sim merge, that is actually not using only one merging technique, but kind of select the merging techniques based on some of the metrics. We kind of applied this sim merge recipe to find the best merging technique, merging method, also merging what layers to merge question. Evaluation. I think this is very interesting. I would like to mention maybe like five minutes or so, then I can close and get the questions there. But our evaluation is slightly bit different than maybe you see in other technical reports, because one reason is multilinguality, but also we see that evaluation should not only be, okay, these are the scores, downstream benchmark scores, like just accuracy based, but we need to understand the broader, more holistically, how good the language model in different areas, right? And that's why when we look at the evaluation, in terms of the languages, we did not only take like, okay, this is the full average of the performance, but we kind of carefully picked diverse languages to have a better sense of how balanced this model in terms of the broad coverage. That was one thing. Second thing, instead of heavily using discriminative task, which is like a, let's say, multi-choice question answering, we more looked at the generative tasks, because this is how people are using these language models, right? Rather than asking a multi-choice question answering, we are trying to like use this like a prompting language model and get a completion. So we try to understand how good our model in generative performance. And in terms of the metrics, as I said, instead of looking only accuracies, actually we look at, of course, we looked at accuracy, but also we looked at language confusion, like because there are 70 languages that we are optimizing for, how consistent model is generating into a language, how natural model generation is, and how good the model in terms of instruction following. And we try to come up with a more holistic view when we are showing the comparison. These are some of the benchmarks that we kind of used, but there is always a question, right? There is a benchmark, let's say, arena hard, how to expand this arena hard coverage into a larger set of languages. Translation is one way to do that. So we also applied prompt translation, but it's automatic, but imperfect. We also kind of combined different benchmarks there to get a better coverage, but both in terms of the tasks, but also in terms of the languages. So one question then, in terms of the evaluation, when we start, should we use sort of win rates, which you prompt two different models and you compare models generation and pick which one works best, right? This is very common technique in the language models comparing different languages. Or should we come up with something new? And as we do the lots of evaluation with the win rates, we end up not using win rates, because there is lots of problem with like using two language model and like a very binary choices. Variance, anchoring, and interpretability are the main problems. But actually, I want to show this with one simple example here. When we in the first iteration of the post-training, we were using win rates and comparing our model with geometry 4B, and the evaluation results was like a 90% win rate for Tiny Aya against geometry. But actually, this was not because Tiny Aya was really, really good at Welsh, but Gemma was really bad at Welsh. So if we only use win rates, we would probably miss any like a progress point in terms of Welsh, because maybe Tiny Aya was also not really performing well in Welsh, but it's just generating natural text in Welsh, maybe not really answering the question. Actually, this was really kind of turning point. Okay, maybe it's not the win rate for us. So returning back, instead of using win rates, we used rubric-based evaluation with the different criteria. There we use 4 different criteria: accuracy, instruction following, coherence, and fluency. And we use 7-point Likert scale, so that we actually get balanced, but also like a free from this anchoring problem evaluation. Balance as in you still get a comparison with any other model, but you also get a better understanding of where this model performance is in that task and that language. Of course, this still requires a judge model, and we use their GPT 4.1. And in our preliminary experiment, GPT 4.1 end up being really well in terms of comparing different models and giving a kind of balanced performance metric fit this Likert scale. So now I can go through a little bit on the evaluation. As I said, this is the least part that we kind of focused, but still important to show. Discriminative results. Here we looked at global MMLU because there is a large coverage. In global MMLU, we looked at include and we look at global PQA. As you can see, TinyAI model actually does not perform bad. It performs significantly okay, but we didn't optimize TinyAI for this multi-choice question answering dataset. So that's why it's not the where TinyAI actually shining compared to the other models here. But where TinyAI kind of shines, where also we kind of focused when we are optimizing post-training TinyAI, is actually generative tasks. Here we looked at multilingual Dolly, multilingual Arena Heart, global MGSM, Flores, and WMT. So all of them actually kind of correspond slightly bit different downstream kind of use case. For example, multilingual Dolly is much more conversational.
Yes.
All right. Arena Heart focus on much more harder tasks like a coding or math. It's not really math, but there's lots of coding questions in multilingual Arena Heart. MGSM, global MGSM is multilingual mathematical arithmetic task. Flores and WMT are translations, but all of them is generative, right? Here, really, TinyAI's performance is pretty strong. I think either best or second in some of them, but in general, very, very competitive. And in the translation is really the best, even better than the Qwen 3.5, which is released also very recently, and which is a very, very strong model. This is, I think, is kind of summarizing our evaluation very briefly. Here we kind of look at, because not only about the average scores, but also we want to have I think one of the highlights of this talk is like a balanced performance as well, because we want to have high performance in broad coverage of languages, right? Rather than having a best performance in few languages, but not really worst performance in some other languages. This line here kind of shows how high resourced is a language. We can, as a proxy metric here, we use the number of Wikipedia pages in Common Crawl, not Wikipedia, sorry. And the bars are showing the performance. And as you can see, the green bar, TinyAI, is competitive and pretty good at high resource languages, but also very close to its high resource language performance in the lower source languages, like especially in the last bar, really shows how balanced this model is if you look at the 70 languages, which was really one of the important points when we are developing a TinyAI. These are some results from translation. Here we actually compared not only Gemma, but also Translate Gemma, which was also released very recently. There is, TinyAI, as you can see, generates, of course, there are lots of numbers and lots of languages here, but very competitive performance here in a broad range of tasks. Another, maybe my final point in terms of the evaluation, we not only look at this pretty well-defined task, but also we look at the broader downstream, holistic approach in terms of evaluation, and safety was another thing, because multiple papers shows the adversarial prompting, like a kind of jailbreaking to multilingual language model, it is much more easy for lower source languages. And we kind of try to understand is it also the case for TinyAI? And as you can see here, TinyAI performance is actually quite good compared to the other models, which was really nice thing to see for us. Within this holistic approach, we also looked at this cultural performance in terms of the cultural nuances, and a main comparison here would be like how TinyAI kind of compares with Gemma and broad range of tasks, and we see quite a good performance here. As a upper bound, we also looked at Command A as kind of a much more like a capable and much bigger model. And it's actually, if we only look at this, the difference is not, there is a difference, but it's good, encouraging difference here. And TinyAI is able to reach a threshold. Let me put it that way. Yeah. As a result, TinyAI was actually an experiment beyond releasing a model about how to approach building a very large coverage multilingual language model as a design problem from tokenizer, pre-training data, post-training recipe, and evaluation. I think we have innovations in all these different angles, which end up being a release that's like a scientific pursuit rather than just, okay, we train this model and release. I think that was the main thing and how we approached language modeling as a company and as a lab. But still, of course, there are lots of open questions always, especially in the multilingual era. Like this model is not particularly strong in math and coding. This is one of the next steps that people or we can definitely look at it. I was keep saying like a language coverage, broad language coverage, but 70 languages, of course, is not where we want to be. There are a lot more languages that language models should cover. This is, again, a really important research pursuit to look at. And there are also like there is all in the multilingual language models, there's always this translate test versus like the native language performance. This is still another open question, like English prompting, whether like, let's say you have a math problem, you first translate to English, then try to solve the problem, or you try to solve the math problem in the corresponding language. I think this is still something that worth experimenting and researching more. And there are some open questions and next steps in terms of data and cultural understanding. Yeah, as I said, this is like a research from a really big team. This is the core team that drive the experiments and research in Aya. And this was combination of lots of different separate research as well. But beyond this group, there is much more people that kind of help shaping the tiny Aya and Aya research in together. So I would like to shout out to all the collaborators here. And yeah, that's all from my side. But I would like to hear questions, comments. Yeah.
Great. Thank you very, very much for such an interesting talk. It's super amazing. And so much indeed of research happened during this time. So it's super interesting for the academia perspective as well. So yeah, really super cool. And yeah, congrats on the release of the model. I hope you will have like many, many downloads and many people will contribute and research and use it. I have maybe like the first question is, it's like very, very broad question, maybe like still too difficult to answer. So for example, in your model, if I want to improve it or somehow add a new language, like lower source one, but close already to the ones which already exist in the model, do you know like any kind of recipes that I should do to do this?
Actually, this is a really great question. This was one of the motivation when we were working on tokenization. So I cannot say for sure that the tokenization has enough coverage for any language. But one of the things that we really care that we should have one tokenizer that is good enough to also expand this language coverage for a new language. So we try to have at least like significant coverage for scripts, significant coverage for languages. So I believe the tokenizer from the step 0 would allow model to expand it into new languages if it is not completely unseen. But because of our like a weighting approach, even for completely unseen languages, which I will have a remark, of course, I believe a little bit of post-training would allow model to perform in a new language. But if there is a script that model has, or in general, our tokenizer didn't see at all, that would be, of course, then like adapting tokenizer to this completely new script would be a step needed. Otherwise, tokenizer level, especially, model would definitely allow to be exposed to a new language. Yeah, was there a follow-up or no?
Yeah, I think somebody else maybe have a question. Yeah, thank you very much for answering my questions. So yeah, now we'll open the floor for everybody else. You can raise your hand, unmute yourself or write any question in the chat. So yeah, please, more questions are very much welcomed.
maybe I can, in the meantime, if there is any question as they come, I can tell one thing that I noticed that I didn't actually mention much about, which is another important thing in our post-training recipe. Let me find that. I think it was here. Yeah. So I kind of very fast the move here, but one thing that was interesting for me and for our team was actually we experimented with not only SFT. So model of course went through SFT and merging and also alignment stage, which is basically DPO here. But we didn't get a high performance delta when we apply DPO. And one of the idea was there because this this model is small, very small in terms of the parameter size. And when we apply DPO with online or offline data, could be on policy that is generated through model or could be off policy from public domain, any preference pair that we get from internet, we see that model becomes much more brittle. Like model conversational capability was increasing through DPO because I mean, one of the things that you may want to do DPO for, but also model was losing some other aspects on the way. That's why actually we did much lighter multilingual alignment to have to kind of maintain the balance in terms of different languages, in terms of the tasks. And of course, we want to do alignment to make model a bit more, better in terms of, giving the identity and language supporting, and also maintain the multilingual safety. But we did not extensively apply DPO or like any sort of alignment in this model, which was kind of interesting to mention, I think.
Yeah, it's really interesting. Yeah. Thank you for mentioning. So actually, we have a question from Sergey, so you can unmute yourself and ask.
Oh, hi guys. Thank you, Ahmet, for this wonderful presentation. I think it's an important work also for saving language diversity across the world. And my question is about language clustering. You mentioned that basically you clustered languages based on, I'd say, geography principle, like European languages are tied together and Asians together. And did you consider another approach of grouping them not by geography, but by uh, language relations? I'd say Indo-European languages together, Turkic together. And if so, maybe what would you say would work better? Grouping closely related languages together, would they benefit from it? Or vice versa, bringing diverse languages into one group?
I see.
Thank you.
I think thanks for your question. It's actually a really nice point to cover. So our initial point was actually regional link, grouping through the regional, because we, in one side, we really wanted to have this language model to be used well, so that regional clustering makes sense in that context. But definitely having similarity between language families. But also I will add one more thing about script is also very important when we are when we see that when we cluster languages, this make a big changes. That's why not in the post-training level, but from the tokenization level, actually our language clusters is much more granular. So when we are weighting the training data, we kind of clustered based on script and language families. But in terms of the post-training, when it comes to post-training, actually there's quite a bit of overlap between regional clustering and similar languages or similar scripts. Of course, there are some outliers in this picture. Like if you think about Turkic languages or Turkish, I'm from Turkey, I speak Turkish. So it's hard to put Turkey in terms of either regional use or script or language family, because it has Latin script, but it has actually Turkic languages, so it's very hard. That's why, as like a guiding principle, regional use was there, but we always looked at how close a language to another, like a mainstream languages in the corresponding cluster.
Great,
I'm not
thank you.
sure this answer your question, but I just
Sure.
wanted to like show our approach there.
Okay, so we have actually one more question from Galit. So she wrote it in the chat. Regarding evaluation, you mentioned you measured also naturalness, and it was, yeah, probably with LLM as a judge. Yeah, can you just maybe elaborate a bit more about this and how it was done? And is there was actually any human in the loop for some of it?
It's a great point. Indeed, our naturalist evaluation actually was also very similar with this rubric-based approach. We have a rubric that kind of ask how natural. Of course, it's not is like how natural the generation is. There's a much more fine-grained questions in that rubric, but it was majorly, if I'm not wrong, because so I might be missing some of the details there because of the really large team, but I don't think there was at the final evaluation there was no human in the loop. It was mostly LLM as a judge. Yeah, but actually this is a really good point, which we all, I think it's very well known fact in the field there. LLM as a judge, the precision is not the best when you using LLM as a judge. So there are lots of potential noise. How we try to like decrease the potential noise gap there is actually more about making the rubric as good as possible so that language model does not come up with okay, this is the better or more natural generation. It's more about much more fine-grained. So I think there's our evaluation is in the technical report, by the way. Our rubrics are also in the technical report. Probably you can check that, but more about like a really language model try to answer a more concrete question so that it gives a more reasonable answer.
Yeah, thank you once again for answering. I will be like at a very strict cost. So actually, our 1 hour slot is already ending. At the same time, if you need to go, we can already finish the call. At the same time, like if there are still a couple of more questions, we can still have them, probably.
I have time if there's a few more questions to talk about those.
Okay, let's see. Because I actually also personally have like so many questions. I think again like it was really very interesting talk and yeah. You also mentioned about like reasonings and actually maybe like this model is not the best in terms of reasoning. However, again, like I said, do you have like an intuition, for example, if it will be again maybe post-trained for maybe like some high resource language, will it be beneficial for the whole set as well?
For reasoning, actually, I mean, it's kind of how you post-train the model to make as a reasoning model, right? So as I said, this model is not extensively post-trained as with the reasoning traces or with the RL. Both of them, I mean, you either do lots of reasoning, put lots of reasoning traces in your post-training to make the model much more stronger there, or model to reason, or you do an RL there. I think especially I'm just talking based on the model scale. Since model is quite small model, my intuition is having some sort of cold start, you can call it that way, with the reasoning traces may automatically give some reasoning performance to this model, because we see that model is actually able to generate chain of thought, but reasoning models are not exactly simple chain of thought reasoners anymore. So it generates a long reasoning that requires model to be trained with a longer context with dedicated reasoning traces. So I think that would be one approach to make this model a better reasoner.
Yeah, like it's true, but actually you mentioned so you tested like indeed like it's MMLU benchmark, which actually kind of like this chain of thought reasoning benchmark, but yeah, I need like not directly for math or something.
Yeah, I think in terms of MMLU reasoning, for example, model is able to do it, I'm sure, or like MGSM, relatively simpler mathematical arithmetic questions there. But if you put through model to like a live code bench or Amy, then model might have a hard time to solve much harder problem because it's not really trained as a reasoning model.
Yeah, I see. Maybe what we can end with. So yeah, so far no more other questions. However, yeah, maybe to see once again, I don't know, QR code to Hugging Face collection to download the models.
Yeah, let
Is
me share that. Yes, exactly. But yeah, I will also share the slides so that anybody can look at and download the models.
yeah, it would be amazing. Yeah, with the slides.
Thank you very much again having me. It was really nice presenting some of our research here.
Yeah, thank you so much for your time and yeah, for connecting to us even from from a different time zone. But anyway, yeah, everything worked out. It was super interesting, and I believe yeah, super will be useful for many of our participants. Yeah, once again, thank you very much. And yeah, looking forward maybe to meet you at some conferences.
Thank you very much. It was super interesting.
Thank you.
Thank you all. Bye bye.